Good morning, everyone. My name is Kumar Mahendra. My metric number is 23B0222. Today, my group and I will present our analysis on linear regression. What is a linear regression? Linear regression is a basic yet powerful statistical method used to understand and model the relationship between dependent variable, one or more dependent variable. In simple linear regression, we deal with only one predictor, while multiple linear regression involves two or more. In general equation of a simple linear regression is y equal to b naught plus b1 x, where x is the outcome where predicted and x is the predictor. In multiple linear regression, the equation expand to include more variable. For example, for equation y equal b naught plus b1 x 1 plus b2 x 2 plus and so on, depending how many independent variables we have. This method is widely used in for forecasting, prediction, and understanding how variables are interrelated. Okay, for our project, we use a data set containing data from 20 randomly selected car buyers. Each customer records are three variables. I attach the graph. Age, which is the age of the customer and act as an independent variable. Income, which is the customer annual income in thousand of ringgit Malaysia, also an independent variable. Car price, which is the price of the car purchase, serving as the dependent variable we aim to predict. The data set was scientifically generated to simulate realistic market behavior into the site random nodes to reflect real world variability. Since we have a two predictor, age and income, and one outcome, car prices, the setup is deep for multiple linear regression. Thank you.
Assalamualaikum. My name is Nurul Najah Husna binti Mat Kecil. I will explain three key concepts in regression analysis. First, linear regression. Second, homoscedasticity. Third, normality of residual. First, linear regression is a statistical method used to predict the value of a dependent variable y based on one or more independent variable x. There are two types. First, simple linear regression with one x variable using the formula y equal to a plus bx. Second, multiply linear regression with more than one x. Next, we have homoscedasticity. This means the residual or the error between actual and predicted value have a constant spread across all value. It's important because if the variable is not equal, known as heteroscedasticity, it can make the statistical result inaccurate. We usually check this with a residual versus predicted value plot. A random spread means the assumption is made. Lastly, we look at a normality of residual. This means the residual should follow a normal distribution or a bell-shaped curve. Normality is important because to ensure the result of hypothesis tests like p-value are valid. We can check this using a histogram, Q to Q plot, or a normality test like Shapiro wheel. In conclusion, there are three concepts help to ensure our regression model is reliable and valid. Thank you.
Hi, my name is Nurul Salsabila Betty Ibrahim. My metric number is 23A0107. In this slide, I will explain about linearity. Linearity means that as one variable s increase or decrease, the other variable y also change at the steady or proportional rate, kind of like a straight line pattern. This is important because when the relationship is truly linear, we can make accurate prediction using a simple and reliable model. But if linearity fails, then our model will make poor prediction. And when we look at the error, they won't be random. They will show a clear pattern. So how do we check for linearity? First, use scatter plot. If the point roughly form a straight line pattern, That is a good sign. And second, look at the residual plot. The error should be scaled randomly around zero, without any visible pattern. Here a simple example for linear regression. We have three houses, house A, house B, and house C. If we draw this on the scatter plot, the blue dot shows the data point. The red line is the predicted linear trend. It fits the point well. This shows a clear straight line pattern, which is exactly what we want for the linear regression model. Next is independent of error. This means that the error or residual in our model should not be related to each other. In other words, one error should not help us predict to the next error. Why does this matter? When errors are uncorrelated, our model is reliable. We can trust the estimate and tests like t-test and f-test. But if errors are correlated, we may get inaccurate estimates, but our test could give misleading results. That is why making sure the errors are independent is so important in regression. For example, if we are predicting daily temperature and today error is 2 Celsius and tomorrow also 2 Celsius, there is a pattern which violates this assumption. In the top graph, the good model error looks scaled and random. In the bottom graph, the bad model error follow a clear pattern, so they are correlated. When errors are independent, our model more accurate and reliable.
Multi-collineation content. Multi-collineation is a high correlation between predictors. Problems. Unstable conviction are to inflect standard errors. Detection. Collection metrics. Then the fixes are remove or combine variables. Use PCA or Lazio rich regression. Conclusion. Unstable linear regression helps predict and understand variable relationship. Assumptions like linear, normality, and no multi-correlation must be met. Violation is less accurate models. When exceptions are followed, regression becomes a strong decision-making tool. Thank you.